Solution to the question of the day. The question is, find the area enclosed between the curve y equal to s squared plus 2 and the line y equal to 4s minus 1. First and foremost, recognize the fact that the limits of the area you have to calculate is not given to us directly. But we can get this limit by solving the two equations simultaneously. So therefore, we have our s squared plus 2 should be equal to 4s minus 1. Now, this becomes s squared minus 4s plus 2 plus 1 equal to 0. And that is our s squared minus 4s plus 3 is equal to 0. Factorizing this, we have minus 1 and then s minus 3 and everything equal to 0. Therefore, our s is equal to 1 or our s is equal to 3. So the limit we have established by this process. So we are going to integrate our function between the points 1 and 3. So in this regard, remember that we are finding the area enclosed between the curve. Let's sketch what it looks like. So we have something like this. I'm sketching this now. This is our s as this, our y as this. This is the origin. And then of course, when you talk about the curve, when s is 0, y is 0, so it's starting from, okay, when s is 0, y is 2, and then when we take this from 2, and we have a curve. Then let me still make it better. So let's say we have something like this. Okay, and this is your y equal to s squared plus 2. What I actually did to start from here was to make the value of s equal to 0. That will definitely give me the value of y to be equal to 2. So I assume that this point is 2. So I'm not starting my curve from the origin here. So after that, we are also told that our y is equal to 4s minus 1. Let's see what that will be when s is 0. And then we have y to be minus 1. So starting from the bottom. And so we may have something like this. And here, this point here is your s equal to 1. And then this point here is your s equal to 3. Remember that this is your curve, or your straight line, y equal to 4s minus 1. You are interested in the area enclosed, and this is the region we are interested in finding the area. And of course, the y equal to 4s minus 1 occupies a greater region than the curve y equal to s squared plus 2. So that we need to integrate this and subtract the value of the integral of y equal to s squared plus 2. So we go on to say now that the area under this curve will be integrating from 1 to 3 of your 4s minus 1 with respect to s, and then of course minus, we need to integrate the same limit 1 to 3 of your s squared plus 2 also with respect to s. Now if you look at this, if you integrate this, what will you get? 4s squared over 2, 4s squared over 2, and then minus s. Okay, and this will be evaluated from 1 to 3. Minus, if you integrate this, you have s cubed all over 3 plus 2s, and then you evaluate this also from 1 up to 3. Okay, this will be equal to 2 will divide 4 to give us 2, and that is s squared minus s. We will evaluate this at s equal to 1 and s equal to 3. Then of course minus, open the bracket, we have s raised to power 3 all over 3 plus 2s, close the bracket, and evaluated at these limits. Okay, You can close this. Now substituting s equal to 3. 3 squared is 9. 9 times 2 is 18. And then 3 here will be minus 3. And of course, minus, substituting 1. So we have 1 squared is 1 times 2 is 2. And you see I'm opening the bracket because of the minus sign. 1 here is minus 1. You close the bracket. Alright, you move on to the next one, minus. Again, open the bracket. 3 here is 27. 27 divided by 3 will give you 9. And 3 here is 2 times 3 is 6. That is plus 6. Then remember, this is minus. What do you have there? 1 raised by 3 is 1 all over 3. So 1 over 3. And then we have plus 2 times 1 is 2. We close this and then we close this. Okay. Of course, 18 minus 3 is 15. And then this is minus 2 minus 1 is 1. Then we have here minus, open the bracket, this is 15. And then we have minus 1 over 3 plus 2 is 2. 1/3, which give you 7 over 3. So we can have it as a 7 all over 3. Close this. That eventually will give you 15 minus 1 minus 15, and then we have plus 7 all over 3. Let's see what we have with this calculation. 15 minus 15 is gone. So we now have minus 1 plus 7 all over 3 minus 1 plus 2 1 over 3, and that will be equal to 1 over 3, and that translates to 4 all over 3 to agree with the options given to us, and this is equal to 4 over 3 square units. 4 over 3 square units, and the option B is the correct answer to this problem.